All right, so we got 171, 173, and then page 253, which is not a homework. It's not in the homework section. It's a page out of the notes. 253, and then what is it? 182. Okay, 182. Okay, so that's what we got. And the 2D problems are somewhat similar, and the 3D problems, the both of them are somewhat similar. So let's have a look. Okay, why don't we start with 171. So do we got questions with this one, 171? All right, so on 171, what you want to do here is you want to draw a free body diagram of the ring. When you draw a free body diagram, you put a boundary around the object. Anything you cut through has the potential to create a contact force. So I cut through those 3 cables, so each one of those then can create a force. Remember, cables pull is what they do. So we've got each of those cables pulling. Now I want to know the angles at which they act. So I'll do inverse tangents there, arctan. Now what an arctan does is it takes y over x, calculates it, then finds the angle that has that proportion of y to x, okay? So if you have a delta y of 1.5 and an x of 3, that equivalent angle there is 26.6. And then if you have a delta y of 4 and a delta x of 3, the equivalent angle there is 53.13. So once I have that, I can create that free body diagram, or force diagram, whatever you want to call it. So there's the diagram of that ring. Do we have any questions on that diagram? So what I've got there is I've got a 2D problem, okay? And I've got 2 unknowns, FAB and FAC. The unknowns, there's 2 of them. So with 2D, I've got 2 equations, some of fx, some of fy. So that's solvable. Okay, I can solve that. So I do want to get those angles in there because that's known information that I'll need to solve it. All right. Are we good with that? We got any questions? Okay. So then I can throw those 2 equations at it there. Some of fx is 0, some of fy is 0. Now, if I have a solver on my calculator, you can use that and just go, if that's how you want to do it, just if that's how you're solving out your equations that you generate, remember to show work though. So if you've got I don't know, what's the current TI that most people have these days, or is there such a thing? Is there one on a different one now, or what? 84, okay. TI 84, just solve it like that if that's how you solve it, okay? You don't have to show any more work than that. Just bang, okay. That way I know the answer just didn't come from looking over at your friend, that you actually ran it and know how to run your calculator, or work it out, either way, okay? So I've went ahead and worked mine out, okay? All right, now, when I work it out by hand, which, you'd have to do on a test, I'm going to try and get this the easiest way I can do. I'm going to have 2 equations, 2 unknowns. I'm going to start with sum of fy equals 0. The reason is all I have in that is FAB and FAC. I don't have anything else in there. That 860 Newton force goes only in the x direction. It does not have a y component. So if I start with sum of fy equal to 0, then I can get a nice simple relationship that I can plug into sum of fx equals 0. So that's my thinking on this, okay? So I'll start with sum of Fy equals 0, because it's the simplest equation. I can set up a nice simple proportion between AB and AC, and I can substitute that into sum of Fx equals 0. That's my thinking on this, okay? That's the process I go through to work this out. Any questions on that? Okay. So I'm going to go sum of Fy equals 0 first. And what I'm going to do, I'm going to use the sine function because I've got angles with the horizontal. So if I go sine of 26.6 times that unknown FAB, what I get is the y component of that vector. And similarly, when I go sine 53.13 times FAC, I get the y component of that angled vector. So I'm just using trigonometry. I've got angles with the horizontal. So if that's the case, the opposite side from the angle is the sine function. And that gets me the two y components. I've got the AB is up and AC is down. So when I run those numbers, I get 0.447 FAB minus 0.8 FAC is 0. So I can work through that and get that FAB is 1.79 times whatever FAC is. Okay. So that's the ratio between AB and AC. Are we okay with that? Questions on that bit? Okay. So I get the free body diagram. Once I have that, I decide sum of Fy is the way to start. So I run that first, get a nice proportion. Then once I've got that, I can go sum of Fx is 0. So what I'll have there is sum of Fx is negative. Now I'm going to use the cosine function this time, because again, with an angle with the horizontal, the cosine function will get me the x component, the adjacent to the angle side. So I'll get two forces to the left, ABx and ACx. They're both to the left, so they're both negative. Cosine 26.6 FAB negative and minus cosine 53.13 FAC. So they're both negative. And then I've got 860, which is that force to the right. So I can go ahead and, manipulate that algebraically. Then I can pull the unknowns to the left-hand side of the equation. So 0.894 FAB plus 0.6 FAC is 860. And then what I know here is that FAB is 1.79 times FBC. So I can take that and I can plug it in right there, like so, okay? So that'll get me one equation with FBC that I can solve, and it's 391. And then I can plug in 391 in for FBC and multiply by 1.79, and I'll get FAB as 699. Okay. So that's the drill on this, okay? Get a free body diagram. Make sure you only got two unknowns because you got two equations to solve. And then use trigonometry and vectors to set sums of forces equal to 0 in the x and y directions. Okay. few steps there on the algebra to work through that. Got any questions on that one? Doing all right? So that's the first one. Now the second one is quite similar to this. Just has a couple other little twists and turns on it, but it's the same, very much the same idea. Okay. So we got any questions on this one? You doing all right? Okay. All right. All right. Now this next one here, it's like I know I was in a little bit of a rush when I did this, and I forgot a letter there, or a word. Should have said same. So A and F are not at the same elevation. So I asked you to find the angle of DF, and you're not going to use geometry to do that. You're going to use a little bit of equilibrium to do it with. Okay. So on this one, you're going to end up with a very similar type problem to what we just did. There are a couple little embellishments with this one, I guess you'd say. First thing is you're going to get 30 kilograms converted into newtons. You don't do statics with mass, you do it with weight. And I think is that 294 newtons? I think that's what that comes out to be. Okay, thanks. All right, and then what you do is you run that around the pulley, because you want to draw a free body diagram of the ring to solve this. There's too much stuff going on there to include everything in your free body diagram. So I would make my free body diagram look like that, okay? So it becomes very similar to the previous one, at least the basic solution of this. So you're going to have 294 going that way, and then the two unknowns going up left and down left. And then you've got the dimensions on there where you can trigonometrically figure out the angles at B and for AB and BC. Okay? And then you'll do some equilibrium on the ring. So y'all okay on that? So you're going to have that ring, and then you'll just have these vectors doing that. So do we got questions on that? All right. Now, the other thing we'd like to know is that angle for DF. I'll let you kind of chew on that and figure it out. I will tell you that it's not about solving out a geometry problem. It's more about an equilibrium problem. And what you know is that that pulley is in equilibrium. You know, anything in this system that you care to look at is in equilibrium. So I think if you were to draw a free body diagram like that orange outline, you might be able to figure out the angle there. You could also just apply some common sense to it. There's different ways to solve it. I mean, just let me know what that angle is there. I don't know, are there any questions that come up on that? You good with that? Yes, question?
Will that make the magnitude -294?
On this one, this side? Yeah. Absolutely, yeah, right. Because, yeah, cables always pull, so, yeah, that's a good point there. When you use the free body diagram of the pulley, the 294 will go to the left, because, you know, that it always pulls. Cables always pull. So the direction of the vector can change depending on which side you're looking at, which free body diagram you're doing. So when you do that, yeah, you're going to have this going that way, like so. Okay. Other questions? Okay. All right. Okay, this one here. This is page 253. All right, now you do want to pay attention on the dimensioning on this thing. We already went through F1, I think. F2 we went through. And then F3 has dimensions that are kind of similar to those on F2. So notice those dashed lines that dimension the endpoint of F3 are parallel respectively to the Y and Z axes. So that should give you some clues about F3. Okay. So what you're going to want to do is vectorize all of those. F4 is directed along the negative x-axis, so that should be very easy to make into a vector. Okay. So we good with that so far? So there's a very specific approach on these things. What you do is you start with by vectorizing everything. So we got F1, F2, F3, F4. So we're going to have 4 vectors, okay? Once you have everything made into a vector, and we went through that, here's the deal on F1. Just, get the vector itself, which is 2 minus 3, 6. Take the square root of some of the squares and get 7. Divide through by that and get a unit vector and scale it up by 4,000. And you'll get F1. Okay, so that's where you would start with that. So that's F1. Now, once you have F1, you also want to get the others, of course. So there's F2. Now, as we went over with F2, when you look at that for F2, what you've got is a 27-degree angle with the x-axis, and that's just given directly. We know that F2 is in the xz plane, so there's a right angle between that and the y-axis. So regardless of where F2 is in the xz plane, it makes a 90-degree angle with the y-axis. And then we've got the fact that F2 is in the xz plane. So if you take that 27 and add it to the 90-degree angle between the z-axis and the x-axis, those are both coplanar, both of those angles, the 27 and the 90. So when you add them up, you get 117. Okay. So that'll get you the 3 angles for F2. It's 27 for the x, 90 for the y, and 117 for the z. So those are alpha, beta, and gamma, respectively. Okay. Okay, with that. So we get F2 is whatever the unknown magnitude of F2 is times cosine 27. And it looks like I got a little bit of a typo here. I put a 0 in there. I probably should have put a cosine 90 in there just so we know where the 0 comes from. And then cosine 117. There's other trig functions you could put in for that last one, just depending on how you look at it. All right. So when you run through that, you get 0.891 F2, 0, and negative 0.454 F2. Okay, so that's the vector for F2. F4 is pretty straight up. I think I want a vector head on that too. F4 just goes back in the negative x direction, no big deal there. Okay, pretty straight up. And then F3, just do it a lot like you did F2. And just do it yourself, get a little practice on that. Check in with your friends. Hopefully you got some smart friends. They're always good to have. So I passed my electrical fundamentals lab. I told the smart guy he was going to be my lab partner. Just informed him of that so he'd know it, and he was amenable to that, so I did fine. It's always good to know smart people. I'd recommend that. It's a good skill to have in your life. Electrical fundamentals, they told me the electrons are going this way, but we actually measure the holes going the other way, and I kind of went, what? You're measuring holes going the other way for? And I don't know. Just didn't take to that too well. Anyway, there we go. So there's our, now what you do when you got those vectors, you got F1, F2, F3, F4, you put the vectors themselves in columns. Those correspond to the X, Y, and Z rows. And then when you add each of the rows up, they equal 0, okay? So basically what you're doing there is a 3x4 matrix. Is that what you call it? I can't remember. I think you call the rows out first. So that's a 3x4 matrix, okay? Now, I'm probably never going to give you one where you actually have to use a matrix approach to solve it. You know, you can just algebraically kind of work your way through this one, okay? Okay. So you just, that's the approach to working these things out. Okay. So I think you'll do that y equation first from the look of it, I think. Because that'll only have one unknown. Okay. So the first step is to make everything into a vector. When you've got unknowns, you factor the unknown magnitude through the vector. Okay. We good? All right, good. And then we just start to work through the equations. So there are the equations. I did the y equation first, and I got the magnitude of F3. It's 2175. Oops. There we go. That's the magnitude of F3. I can plug that in everywhere I see an F3 in my equations then. I can do sum of Fz, and I'll get F2 is 4603. And then once I know that F2 is 4603, I can plug it in everywhere I see an F2, like into that x equation. And I can solve for F4. It's 5244. So there are the three solutions for the three unknown forces. Okay. So I'm just putting those vectors into columns, and the rows become x, y, and z equations. That's the deal. Okay. We good with that? We got questions on that so far? All right. Now, I think there is one other step to this one, because what you have there are magnitudes. If those are wires, this would be the force in the wires. But you also might want to take your answer and turn it into a vector. Did I ask that or no? I can't remember.
Yeah, so his answer is expected.
Yeah, so I want you to take those magnitudes and then run them back through the vectors to turn those things into vectors. So just go back to your equations like I got down there. And everywhere you see an F2, plug in 4603, and F3, plug in 2175, and F4, plug in 5244, and then you'll get vectors in the columns, okay? So the columns with the numbers plugged in is what the answers will be, okay? So I don't have those anywhere, but there we go. So there's F2, F3, and F4 as vectors. So there's the answers, the final answers that I'm looking for. So we okay with that? All right, All right, so 182, all I wanted on 182 are magnitudes, right? Now it's the exact same process as this. It's got a few things going on there. But you know, 182 is like doing this, like doing page 253 all over again. It's got one little thing on it maybe that we should look at. So I guess the first thing we should do is get a color that we all can see. There, 182. Okay, so the thing with 182 is you have this ball here, and then you've got these different forces pulling on it. So what, you'll have FOA doing that, FOB doing this, and then you've got the wind force doing that, right? Is there a weight on this thing?
Yeah.
So the weight, of course, it goes straight down. Oh, wait, 9,000? Okay, great. There we go. 9,000. Now, what you've got then is OC doing that. And then you've got the axes put on here. And we've got an x-axis like that. And then we've got a y-axis like that. And then we have a z-axis like that. Now, what you've got to tell you about OC is one dimension line kind of going off like that. You all seeing that okay? That dimension line. Now, what is that telling you about point C out here? Where is point C at? I didn't use two lines on this one, I just used one. Point C is what?
Negative x?
No, it's angling up. See, it's above the XY plane. Because see where that line starts? It starts up higher on the z-axis. So that means it's above the XY plane because that line there that I've drawn in orange is parallel to the x-axis, yeah, okay? So what we're doing here is we're starting on the z-axis and we're going out in the x direction. You all okay with that? Yeah, I'm kind of going over this because I want you to learn how to read these dimensions, okay? So that's starting on the z-axis going in the x direction. So that's in the xz plane is where it is, okay? And in order to really solve this properly, you have to see that. And I've tried with that dimension to kind of show that, but that's difficult to do sometimes, you know, in 2D, especially with my crude AutoCAD skills, but there you go, okay? Y'all okay that's going on there? Okay, and then you got that 75-degree angle shown from the z-axis. So what do you suppose the angle down to the, yeah, would it be y-axis? Let's see. Now that angle is in the XZ, okay, so that's 6. Okay, now that doesn't go down to the y-axis, does it? So you're in the XZ plane, you're given the angle with the z-axis. So what's the other angle you can get out of that? Yes, right. So you can figure out pretty quickly what the angle is to the x-axis for that one, okay? That one's it's drawn correctly, but it does, you know, it looks a little different than the others, a little bit trickier, primarily because it's in the negative x direction. If I wanted to kind of embellish that, I guess, and why don't I get another color here just so we're kind of clear. I've got 2 minutes. Can he do it in 2 minutes? I don't know. There we go. Okay, if I really wanted to embellish that a little bit, I might have done something like that. I don't know if that helps. Might make it worse. I don't know, but that's a little dicey, huh? Okay. See, I've got a rectangle in there that's normal to the XY plane, right? So that that point OC, or point C, is in the XZ plane. So if I want to get the angles that that thing makes, I'm given the 75 degrees, right? This one. Now what the other angle I've got is with the x-axis, and see that one I'm running out of room, but that's coming over like that. See, that's what's going on. You all good with that? And and really all you need is what's on that piece of paper. That dashed line coming off the z-axis parallel to the x-axis tells you that point C is in the XZ plane. That's enough to figure that out. Okay? So yeah, I do want you to learn how to read these dimensions in 3D, okay? And then you should be able to work through that. Do you have answers for this?
Yeah.
You do? And just magnitudes, what do you got? I don't know what that you got for magnitude. Just the magnitude, okay, great. Okay, so see if we can work through that one. Those are due tomorrow. At least that will take you a little time, of course. Careful on the signs. Take your time doing the calcs on that. It might save you time in the long run. Okay, we good?